Okay, let's take a look at a practice question that might be typical of what you would see on the SAT. This happens to come straight out of the Princeton Review book. It's a problem 18, so it's perceived as being difficult. I think you'll see when we see how this is solved, it's probably not all that difficult if you remember the rules that I covered in the basics about transversals. Let's look at what they're asking here. They say in the rectangle PQRS above, what is A plus B in terms of X? Now, several important things here. It's a rectangle, so automatically we know what? We know that we've got two sets of parallel lines. This is parallel to this. And we know that every one of these corners of that rectangle are 90 degrees each, okay? So we know all that. Now they want to know A plus B in terms of X, and they give you X here, but they put A way up there and B way over there. So what do we do with that information? Well, let's call upon our knowledge of transversals and the angular relationships. And the first thing we're going to look at, let's look at this A degrees up here. And we'll look at this parallel line situation between these two. This is an interior angle, and so it's equal to the alternate interior angle. So that means this angle right here is also A degrees. Let's turn our attention now to these two parallel lines over here. And we see B degrees over here, and it's also an interior angle, and its alternate interior would be from here to here, and it would be B degrees. Now we want to know what A plus B is. Well, in order to do that, I know that all this has to add up to 90 degrees by the complementary rule. And so I can't just say A plus B equals 90 degrees because I have this X in here, so I'm going to have to back that out. Minus X degrees equals 90. I know that from the complementary angle rule. Now we look down through here and they want to know A plus B in terms of X. So I got to get X over to the other side. So I'm going to use the inverse rule, plus X here, plus X over there, and I get A plus B equals 90 plus X. And if you look over here, that happens to be A. Okay, let's take a look at another example. This happens to be a circle with two triangles that are inscribed in the circle. And this has a number 5 attached to it here, so it's supposed to be easy. Some of you may think it's easy, some a little hard, depends on the person. Let's see what they're asking here. If XY and XZ are diameters with lengths of 12, what is the area of the shaded region? Now the shaded region are the two triangles. WY happens to be a diameter line of the circle, and so is XZ. I didn't draw that very straight. So we know that both of those each are 12. So keep that in mind. The other thing we need to know now is the area of the shaded region. Well, let's just say the area of these two triangles. And you're saying, oh my gosh, I can't remember the formula for the area of triangles. It's not something you do every day. Don't worry. All the formulas for area that you need to know, all the formulas for volume, circumference, there's a cheat sheet right in the SAT that you're allowed to use. Let's take a look at that cheat sheet together. Here we see the cheat sheet, and you have the area of a triangle right here, and then you have some special triangles. You see the Pythagorean theorem, circumference, area of the circle. So these are things that you can use as you go through this problem. Let's go back to the problem. Let's see what else we know about this. They gave you 135 degrees here. They did that for a reason, because they want you to think, that means this angle right here, since by the supplementary angle rule, they have to add up to 180 degrees, that this has to be, just draw an arrow there so you can see it, 45 degrees, that angle. And if that's 45 degrees, and this angle right here is 90 degrees, and we know it is, it's got that little rectangle there, then that means this one right here also has to be 45 degrees. Now that's very, very good to know. And the same thing here. If we look at this line, this angle right here has to be 45 degrees because of that supplementary rule. And this angle right there has to be 45 degrees. So we have a situation here where these two triangles are identical. They're triangles, right triangles, with two of the angles each being 45 degrees. So let's look back again at our cheat sheet. And the reason I want to look back here, that happens to be one of the special cases you see right here. And it says that the relationship with the sides, when you have a right triangle with two 45-degree angles, is that the hypotenuse is one of the sides multiplied times the square root of 2, and that the two sides other than the hypotenuse are equal to each other. So we want to use that information, and we also want to use this information over here, the area of a triangle. Now, if the base and the height, here's the base and the height of a 45-degree, 90-degree right triangle are equal, then we can just change this formula here to be A equals 1/2 S squared, because we're taking base times the height, and they happen to be the same thing. So keep that in mind as we go back now and we write down a few of these things that we're doing. So what do we know? We know that this side right here is S times the square root of 2. And we know that this side right here is S times the square root of 2. We also know that those two segments together have to equal 12, right? Because that's the diameter length. So we know that 2S times the square root of 2 equals 12. We then divide each side by 2, divide this side by 2, this side by 2, that these will cancel out, and that S times the square root of 2 equals 6. And to get S by itself, we divide by the square root of 2. We know that S equals 6 over the square root of 2. Now, a moment ago, we wrote down that the area, if you'll remember, was going to be 1/2 S squared. So we know what S is now. We can just go ahead and write that out, that the area equals 1/2 times 6 over the square root of 2 times 6 over the square root of 2. Okay, let's simplify that. When you multiply two square roots times each other, they become a whole number. And so we'll take the denominators times each other first. We get 36 And square root of 2 times the square root of 2 is 2. And we've got to multiply that times the 1/2. That gives us 36 over 4, which equals 9. Now, if you're Joe Boggs, all of a sudden you say, oh, I've solved it. You're forgetting one thing. Now, Joe Boggs is going to go, oh, I think it's E down here. Now, he would be wrong, because what they're asking for, what is the area of the shaded region? And they have shaded both those triangles. So we have to take 2 times this 9. And 2 times 9 equals 18. That's your final answer, C.